essentially you have a piston that is suspended with flexures or springs that allows it to rotate back and forth and with very little friction. Each of our units abates, prevents the emissions of about 1,000 tons of CO2. So that drove us to offer an additional business model, additional in the sense that customers have the option.
Welcome to episode 16 of Crownsmen Energy. Today we are joined by Ory Zik. He is the CEO of Qnergy, the world's leading clean technology manufacturing of Stirling Energy systems. And he is here to talk about their offerings of compressed air as a service, remote power, and compressed air pneumatics. But before we get started, let's thank our sponsors. First up, we have Savanaugh Equipment. Are you working on pipelines, oil and gas projects, renewable energy, or LNG and need to save some cash? Visit Savanaugh Equipment, as they have industrial pumps, electrical equipment from motors to transformers, and even surplus pipe and much, much more available now. Visit them at savanaughEquipment.com, where you will find more equipment every day. Next up, we have PowerZone Equipment. When you need a specialized team of world-class engineers for your oil and gas pipelines, dewatering, or any fluid handling needs, you want to visit PowerZone.com. In addition to their inventory of rebuilt pumps, motors, engines, they also have an amazing team to design and engineer your systems, no matter the challenge, no matter the location. Get in the zone with PowerZone. Visit them at PowerZone.com. Well, let's get on with this episode. Here is Jerrod Downey and Ory Zik.
Hello, everyone. Welcome to Crownsmen Energy. I am your host, Jerrod Downey. Today on the show, we are featuring a pretty amazing company. Qnergy is they're doing some amazing stuff with Stirling generators. And today to discuss it is Ory Zik. He is the CEO of Qnergy. How are you, Ory?
I'm great. Great to be here. Thanks for having us.
I saw you doing these presentations about your product, and right off the bat, you walked out with the like a little model, not a model, like a toy version of what you do, but on your hand. And the heat from your hand was actually powering the engine, right?
Yes.
So let's just jump into it right away. Let's talk about what the product you developed is, and then a little bit of the history of it, because it's absolutely fascinating.
Excellent. Yeah. So the product is a power generator. You have many power generators on the market with various technologies. The Stirling-based power generator has two very unique properties. One, it is very, very reliable. And when we'll talk about the principles of the Stirling, I think it will be clear why is it so reliable. And the second property is that it is fuel agnostic. It can use essentially any source of heat. And these two properties open enormous markets because, everybody wants a more reliable generator. And the fuel agnostic property allows us to play a role in the energy transition, because as the world is moving off fossil fuel into renewable natural gas and hydrogen and these sort of unique heat sources, the Stirling engine is a prime candidate. So essentially we build a power generator. In terms of the history of it, the history is fascinating. The Stirling engine was invented by a Scottish clergyman more than 200 years ago. The patent was registered in 1816. And he was trying to protect children in his community. It was they had coal mines, and the water pumps and other machinery in the coal mines were very polluting, and they were impacting the health of the people, especially children in this community. So he came up with an idea of a very simple engine. Essentially, as you described with the hand initially, if you have air in a cavity and you heat it up, the air expands because gas expands in heat. but then it cools down, so it contracts, but then it sees the heat again, so it expands again. So this creates a periodic motion. And if you attach a magnet to the moving part, essentially you have a magnet moving in a static field, you can create electricity. So that's a very simple invention. Obviously, he didn't think about electricity 100 years ago, but he thought about the mechanical part of it. And what's interesting is that in the last 200 years, many companies try to build a Stirling-based power generator because it's kind of the obvious application. And until Qnergy, nobody managed to actually bring to market a power generator based on this application.
What was the inhibitor? Is there something that got developed? I mean, obviously your company has actually got the generator out into the field working, which is amazing. But what was stopping it over the last 100 years? Was there a technology that got developed recently that allowed it to produce?
So there are a few barriers that were overcame by the industry throughout the years. One of the barriers is that the only working fluid that has sufficient efficiency is helium. And if you think about a pretty large generator that is sealed for helium, it is a mechanical challenge and it is a little bit expensive. The other challenge was a mechanical design that allows the engine to be with negligible friction, essentially no friction. And this brings to something that we call a free piston mechanics. Essentially, you have a piston that is suspended with flexures or springs that allows it to rotate back and forth and with very little friction. So that was another innovation. And the third, which was possible only in the last decade or two, was electronic control. Because once you apply heat to this engine, it starts vibrating, but then if you want electrical output, you need to control it somehow. So Qnergy developed this electronic control. It is controlled by the Hall effect. And Qnergy brought together the mechanical design and the electronic control and the system integration that allows us to build this generator. And the reason, by the way, why these generators are so reliable, the easiest way to conceive it for the audience is if you think about your car that has an internal combustion engine, it needs oil change and it needs all these maintenance interventions because there's a small explosion happening in the car every time the piston changes position. The Stirling engine is sealed, just like your refrigerator has a compressor that is sealed, and nobody maintains the compressor of their refrigerator. As long as it is sealed, it is working. So the Stirling engine is more like a refrigerator than like a car. That's the easiest way to think about it.
So how long? And I want to go. I mean, you've got some pretty good feedback from like NASA and things like that. But how long did it take for Qnergy to develop, take all these parts and put them together to actually develop an efficient version of the Stirling engine?
So the story of Qnergy is actually also a pretty interesting story that happens across three continents and in 200 years. So here in the US, and I'm here in Utah in our factory, in the last 2.5 to 3 decades, like nearly 30 years, engineers were working on the perfection of the mechanics of the Stirling engine. In Israel, where I'm also originated from, there is a company called Rycor that does Stirling devices for cooling, more for the defense industry, with pretty good control capabilities. And about 6-7 years ago, Rycor bought this factory that I'm here, or the owners of Rycor, to build Qnergy. So Qnergy essentially is leveraging decades and hundreds of millions of dollars of R&D that went into perfecting the Stirling engine.
Okay. Yeah, because I was curious about it, because when I was watching and going through, I was thinking the design. I mean, you've got an amazing video out there, because it actually breaks down it by part. It opens up the engine so that you can actually see it operating. And for someone like me, I mean, I just need that to understand what's going on. And I was thinking, this is not like three guys in a basement that developed this. This is not what this is. So it got refined out of the defense, essentially the defense industry then.
Yeah. Yeah, I'm sitting in our 60,000 square foot facility where we build these engines. Yeah, it's a pretty complex operation to design and build them. Our engineers started to work with NASA about 15 years ago, and we've provided NASA one of the early prototypes. And in the summer, NASA issued a press release that this prototype has been working for nearly 14 years without maintenance. So it's the most reliable engine ever invented. If your car would work so reliably, you would be able probably to go to Mars and back without any oil change. It's like an amazing reliability. And NASA is looking at it closely, and we work closely with them, because whenever you think about putting a power source in space, you need to take maintenance out of the equation for obvious reasons.
Right. What Ory, I've seen where you went to university and your degree, so I apologize for the layman questions, but you're going to get a couple on this show. What could this engine? Because during this time, now I mentioned to you before that we'll bring it up so the audience will have seen the video while you're explaining things. Is there any possibility an engine like this could actually drive a vehicle, or would it just be too large of a unit?
So I think the Stirling engine has two major advantages that I've pointed out, but also two major disadvantages. The two advantages are being fuel agnostic and reliable. The disadvantage is that once you start it, it actually doesn't want to stop, right? It has its own inertia. But in a car, you want the ability to accelerate that the Stirling engine cannot provide. Like in your car, you want like this acceleration, this thrust that is not a property of the Stirling engine. So that's a key disadvantage. The other disadvantage, and when we'll talk about market, I will go into it in more depth. The other disadvantage is that in the quantities that we currently provide, we're relatively high cost. So we focus on markets that can pay the premium for the reliability. For example, our interface with the mobility market is not necessarily putting the engine in a car, but as this market goes towards electric vehicles, we can be one of the chargers of batteries in remote locations. Because if you think about an electric vehicle economy, you need to provide charging stations off grid.
Right.
So the Stirling engine is actually a prime candidate for doing that.
Yeah, and I want to get into your business model. You've sort of made it quite an attractive for companies for that to minimize that upfront cost, and I want to get into that in a moment. But just to sort of understand what industries would your application, like you mentioned electric car charging stations. I want to actually dig into the oil and gas section quite a bit, because they've got for running pneumatic devices and that. But what is the breadth that you see that your application will work in?
So there's a difference in every company. There's a difference between the immediate and the long term. But I'll start from the long term. The long term includes, as we mentioned, electric vehicles charging. It includes cell towers, because as many of the cell towers are off grid. Today they use batteries, but the batteries are charged by a combination of solar energy and conventional generators. We can replace these conventional generators, and we've already started. We're already working, with a significant number of cell towers, because the total cost of ownership of having a Stirling engine, because you don't need to maintain it, is much lower than conventional generators. So this is an enormous market for us. There's like more than 300,000 cell towers in the US alone. Another market which is emerging quickly is, unfortunately maybe, is the standby generators for residential and small businesses. If you see, after all the fires in California and all the outages that we've experienced, and if you look at climate change from the point of view of adaptation and resiliency, people want backup power or standby power at their home. The Stirling engine is very quiet, doesn't have any emissions, the CO and NOx, all these that are toxic, and you don't want it at home near children. So it has a very strong advantages to this market. We don't aggressively address this market because strategically we want to do things step by step. But this is another very large market for us. And there are others, but I think these three are cover, tens of billions of dollars: cell towers, EV charging, and residential backup.
Yeah, and you said that residential backup, that's sort of almost a market that you'll likely get pulled into, kind of whether you target it or not, right? Just because of what's going on.
Yeah.
I wanted to, and this is something that I didn't know. And when we talk about emissions is one of these topics that, unless you, like someone like yourself would have a good understanding of it, but if you just hear it at a high level, it really, you go, okay, there's emissions, but you don't know where they're coming from, what's causing them. You'll hear stats like, well, planes put out more emissions than, a million cars, and all this sort of stuff. Very confusing. But it's something I found interesting is that, and I was reading, emissions make up about 15% are coming from the oil and gas section, but that is coming from using gas as a working fluid. And I wanted you to explain that and then talk about how the Stirling engine and your setup, which we're going to get into later as well, eliminates such a huge component of that.
Yeah. So, and this is our main application. This is like what we do when we wake up in the morning. That's what we focus on. The cell towers and the EV charging are the future. So the story is as following. First of all, if you want to reduce emissions, you better work with the emitters, right? It's nearly obvious. Now, the oil and we live in, whether we like it or not, we live in a society that uses enormous amount of oil and gas, or fossil fuel. I mean, we obviously want to reduce it, but that's what we use. Now, in the oil and gas supply chain, there is, in their activities, they emit a lot of methane, because 80% of natural gas is methane. And methane is about 25 times more as a 25 times higher greenhouse gas potential or potency than CO2. Namely, every gram of methane that you emit has 25 times more impact on the climate than CO2. So methane, and if you look at the shorter time frame in the atmosphere, it's even 80. So methane is where you need to focus on, and it's where the oil and gas industry is focusing on, reducing methane emission on their supply chain, because the oil and gas industry realizes that when you use their product, you inevitably emit CO2 because it's a burning process and you emit CO2. But at least all these methane, these potent methane in the production of gas can be eliminated. Now, about 25% of this methane is emitted in a way that can be easily avoided. Some is emitted, and I'll describe it, but it's not what we do. Some is emitted just because of leaks and operations, and these are things that people are flying drones, seeing those leaks and trying to plug. But about 25% is emitted by design, on purpose. It's emitted because they need to emit it. Why do they need to emit it? Because think about those gas operations that are remote from the grid, and they need to open and close valves, whether it's shut-off valves if they need to close something, whether it's a chemical injection pump, whether it's a separator to separate the fluid from the gas, from the water, from gas, from oil. All these need some kind of energy to open and close, to control. Now, if you're in a remote gas site, you have natural gas, but you don't have electricity. So your source of energy is natural gas. So that's the pneumatic devices. Essentially, the industry is using the pressure of natural gas with small auxiliary pipes to open and close and control these operations. But anytime they open a valve, anytime they do something, they emit methane. And this methane emission accumulates to enormous amounts, about 25% of what the industry emits. And the challenge is that about 500,000 of those valves in North America, in the US and Canada. So imagine 500,000 valves that you need to close. So now let's connect the Stirling to this problem. They seem to be disconnected. So the easiest way to connect it, or the solution actually, the known solution, is to replace natural gas as a source of power to open and close those valves with compressed air. Because if you compress air to the same pressure, instead of emitting natural gas, you just emit air. It's plug and play. You just have compressed air instead of natural gas as a source of power. So all you need, the critical missing component, is creating electricity to compress the gas. So that's what the Stirling engine does. It's reliable, so you can put it anywhere you want. It's fuel agnostic, so it can use the dirty, if you want, unprocessed well gas as a fuel. We don't care because everything is external to the engine, so we can work essentially forever with dirty gas. So the process is that we burn a little bit of CO2, negligible amount, less than what your car emits, but then compressed air to allow the industry to avoid all these emissions.
Oh.
And to summarize and to bring it to life with those confusing emission numbers, each one of these systems, which we call CAP, compressed air pneumatic, any one of these systems abate in a year the equivalent of about 250 cars. We made the calculation because we abate about 1,000 tons of CO2, and a car emits about 4.6 tons of CO2. So it's about 250 cars per unit that cost probably like a Tesla car. And that's what we do. We provide electricity to compressed air to allow the industry use air instead of methane for their operation.
Sorry, that 250, that's what you're essentially taking out of the atmosphere then,
yes.
Right?
We avoid, that's the emissions that we avoid. If we don't install the system, then that's what they'll emit.
You're probably better at math. You said there's over 500,000 of these
valves. Yeah, 500,000 valves. Each of our system takes care of 100 valves or so.
I can't do the math. That quick in my head. On if you had a unit on each of these, 1 unit per 100.
Oh, but the easiest way to think about it is the following. Each of our units abates, prevents the emissions of about 1,000 tons of CO2. Each car, a car that you drive, your average American car, emits about 4.6. So 1,000 divided by 4.6 is about 250.
Wow. I want to go into let's talk about the Cap3 because you brought it up. You've got some. Honestly, Ory, it's so nice because we've had guests on the show that they have amazing technology, and after multiple discussions, I get it, but there's a limited visual component, which makes it tough for people who are just. I mean, we have people from all over the industry that are not. I mean, we have an agriculture audience, which you've actually been involved in. So you have a really nice setup. So could you? There's a Cap3 F, M, and L. And can you talk about that? And then you have another chart that shows the PowerGen 560 Advantage. It's sort of a blue chart that sort of lays out the system. And I know you've kind of done it in pieces already, but can we talk about first the Cap3, the 3 different models, and
Yeah.
then the sort of the workflow of it?
Yeah. So the Cap3 has 3 different models. One is like a walk-in bungalow designed especially for the Canadian market, because in the Canadian winter, when it is minus 40 outside, you want to have like a protected place to work. That's a standard, and we've designed it for that market. The Cap3M is more of like a large cabinet, which is much cheaper. You don't need a walk-in bungalow. And the L is designed for a warmer climate when temperatures can go high in the summer, but they don't go very low in the winter. So it's almost like an open bus stop that is open to the environment, because you don't have these harsh environmental conditions. We've just installed a few dozens in Louisiana, so of the L, and installed the Fs in Canada. So that's how we divide them. And the workflow is essentially as follows. We take gas that comes directly from the ground, unfiltered. We use a tiny amount to create electricity. In cold climates, we also use some excess heat to help the operators keep their operation in the right temperature. But essentially, we take the gas, and this is a generator. We take a gas and we create electricity. With this electricity, we run 2 compressors, and these air compressors go through an air dryer to provide clean compressed air to the site. And this compressed air is driving those pneumatic devices. Because our generator is very efficient and it has a lot of excess power, they can use the power also for lighting, for communication, for surveillance, for all sort of things.
So it's sort of amazing that so all these years of having this, like you say, it's over 200 years. I think it was 1816. You said the patent was,
Yeah.
and now that this is getting developed. I actually didn't realize. Of course, it makes sense, but because you have this consistent power, you can power everything around it as well, right?
Yeah.
Okay, I want to talk, Ory. I want to talk about the actual business model of Qnergy, because obviously CapEx. I mean, the oil and gas industry is, I wouldn't call it thriving right now. So, I mean, you obviously I want to get into the details, but did your initial approach, has it evolved as you've gotten deeper into the industry? What was your initial approach, and now where are you now, in regard, especially approaching the CapEx challenge?
So we've been working very closely with the industry. We have now large number of customers, and most of our orders are repeat. People that worked with us, oil majors and small operators, are providing keep ordering. So we specified, which is great for us. And we've also one of our funders is an organization called the OGCI, the Oil and Gas Climate Initiative. So we're very working closely with the industry. We started off by offering just a capital equipment business model. Namely, I provide my generator, I sell it to you, you pay, and then there's a service fee. And as you've pointed out, the industry is not thriving. And during 2020, we heard from customers that it will be beneficial for them if we will come with a business model that don't force them, especially as they install a large number of those units, don't force them to pay upfront. So that drove us to offer an additional business model, additional in the sense that customers have the option. I mean, they can choose. We don't force them, we just give them the option. We give them the option to buy compressed air as a service. The idea is as follows. When you buy Qnergy's system, essentially you bought like a utility pole to your operation, right? You have reliable electricity on site. So the next mental step is now let's give you a utility business model. Instead of buying it, you just pay a setup fee, and then you pay as you consume electricity and as you consume compressed air. So that's why we call it CAaaS, Compressed Air as a Service. And we offer it as an option. It dovetails the fact that in Canada and in the US, we see on the state level, there is operators and producers have the opportunity to get carbon offsets and carbon credits for their activities. So the CAaaS is kind of cash neutral for the operator. Namely, if you're operating a gas field, you can sign with Qnergy for compressed air as a service, and then you get all the costs back from the government because you abated so much greenhouse gas.
I was actually going to ask about that because not only are they giving credits, but in some places there's actually government mandates that are coming out, right?
Yes.
Beyond just some tax credits.
Yeah, especially in Alberta and British Columbia. The practice of emitting methane in pneumatic devices is not allowed in a gradual way. There's a difference between existing fields and new fields. There's a difference between high pneumatic devices that emit a high volume of methane versus low volume. But gradually, this process is being disallowed, and so there's a mandate, and there's credit, and there's also rebate. So there are many ways for operators to buy those devices, but this industry is under multiple stress from the climate perspective, from the gas prices perspective, different perspectives. So this is just an additional one.
Well, I mean, that utility model, I mean, that must have has as soon when you started to roll that out, you said that was just 2020. That's very recent, right?
Yeah.
When you rolled that out, that must have just right away, people must have been open to the conversation much easier.
Yeah. The modus operandi of the industry that we've seen in the last 3-4 years is that people are buying a few units. First of all, they start with one, then they buy like 4 or 5, and then they go to double digits. The first few, they typically feel comfortable paying with capital equipment and just test them. When they need to deploy a fleet of a double digit, then 10, 20, then the utility model comes into play and becomes relevant.
Right. Oh, okay.
Because the check size becomes prohibitive, but if you do it gradually, it makes sense.
Right. Ory, I wanted to I was reading through your bio yesterday, and you know, I do not come from the same background you came. I'm from you know, cleaning up mining equipment, tearing down mines, putting up siding on buildings. That's my background. So I'm always fascinated when somebody comes from. I mean, you went through the Weizmann Institute of Science out of Israel. I was reading through some of their institution, which is an amazing place as well, and going through some of their alumni. And so I want to just talk about sort of how you got here, but also you've become the CEO of Qnergy. And I guess first off, and I'm kind of putting you on the spot to not be humble, but it's a serious question, is what did you bring to the table when you took the leadership of this company, given on your experience, sort of not just why were you chosen, but when you stepped into that door, What did you bring that you were confident you could bring value to this company?
So I think that, well, first of all, why did I come in? I think Qnergy, I was blown away by the quality of the design and the quality of the people. It's really a rare combination. And every company says that we have outstanding people, but it's a rare combination of capable people with can-do attitude. That just, I remember on the first, I live in Boston, so on the first plane ride to Utah to see the factory, I remember reading the material, and I thought to myself, these guys are, out of their mind. They seal for helium. They try to provide the power with the Stirling engine, which nobody succeeded. They control it with the Hall effect. They do so many impossible things. I'll probably come in, walk out, thank you, and bye-bye. But then when I saw the factory and the process and the quality and the passion and the fact that it works, and I just signed on. What I brought to the table, I think, is two things. One is a commercial discipline. Namely, if you have the most reliable engine that is fuel agnostic, you get a lot of people want to work with you, but you need to lay out a commercial strategy, just like we've done with oil and gas and I've articulated, and stick to it. That's what we do, and we need to learn to say no to multiple opportunities. Like every week we have almost a template. No, we will not work with you. It's not our strategy. We're sorry. Thank you and bye-bye. And for companies, it's always hard to have this commercial discipline. That's number one. And number two, because I started my career as a physicist and I have PhD in physics, so I feel that I have enough domain expertise to at least understand what I'm told.
Yeah, that's something I was going to. There was two things you touched on them both, and I didn't know you were going to. But the first thing was I noticed on the website, and because especially companies that are newer, and I mean newer as within like 10 years of being around, that there's sometimes it's hard to figure out what they actually do. And when I go and I was doing my research, I knew. When I left, I understood, and I did notice there wasn't this diversity of concepts. It was very focused. So I did notice that. There is a theme, and I've had people say it on the show, and from their perspective in their career, I agreed with them because it's been very successful for them. It's been successful for me, sort of that entrepreneurial, work with good people, find people that are smarter than you, and find ways to succeed through collaboration. It's actually very effective. But you can't do that if people don't actually understand the science and the physics behind all this stuff that we're doing. So, you've got how much you just touched on this, and the second thing was the education part. How much has the education played a role in your success? You were the founder of Greenometry.
Yeah.
And you've been involved with a couple other companies that you can mention if you'd like. How much did that education that you've got play a role in being able to be a part of be in the leadership position of a company like Qnergy?
Yeah. So it's an interesting point for me. So in my career, I've started a company that was like a microscopy company, Quantomics, then a solar energy company, Heliofocus, then an energy analytics company, Energy Point. The education part, I think, what it gives you is the confidence in learning a new subject and understanding that after a while you'll have some kind of an intuitive understanding of what's going on. It's rare that you will understand the details as a domain expert, right? If we touch about Qnergy's electronic control, it's rare that the CEO will understand, the properties of each capacitor and inductor on the board. But if you have the right background and the right confidence, you'll get the level of understanding that allows you to communicate intelligently and drive things to the right path. And I think that's what management is about.
Yeah. And then, so do you think how much more, I guess to put another layer on that, when you come out of university and you've got your degrees, now you get put into management positions, how much of a learning curve was that? Or were you pretty confident in your leadership skills? Or was that sort of like a whole new education?
So I never had an MBA, but I came out of my PhD and decided that I'm more cut to build products than to write papers, and that took me to industry versus academia. And I had an outstanding mentor in my first company, and he took a scientist and built a manager in a way.
Interesting. What was his approach, like that mentorship?
So first of all, we had a lot of conversations, and he kept emphasizing a few very simple points, which I still take to heart, but they're almost trivial. Always understand the product from the point of view of the commercial applications and the customer point of view. Because as a scientist, as technologies, you tend to try to solve the problems that interest you in the way that interests you, but you need to take the customer point of view. You need to take the financial point of view in the sense that you need to have an ability to estimate how long a product will take to develop, what's the upside, what's the risks, and so on. So you almost in a way, you almost trade the scientific units, the megajoules into dollars, and then but you apply similar tools. But that's maybe not the best way to describe it. But a lot of it is commercial discipline, because you need to say no to a lot of opportunities that are fascinating intellectually, but are just not relevant commercially.
Right. No, I mean, that is a huge thing to say, though, Ory, because it's when you were explaining, I said, like, I jokingly said, so you don't want to hear my ideas. But it is. I mean, you can go even in our little production company. We have such a simple platform, but you'd be amazed at the suggestions that we get. I mean, we could be doing a different version of this show every single day. I mean, I could be reviewing makeup. I mean, people just it's endless, especially when people see you sort of pulling out into the front with new ideas and implementing them. Then you get all those suggestions, and you really do have to say, okay, what is commercially viable? What will people pay for? Because there's 1,000 people that do makeup reviews. You don't want me doing a makeup review, and you have to understand your lane. But it does get almost that extreme sometimes. I mean, you must have, I'm not going to make you call someone out on that, but you must get, I mean, just all kinds of suggestions all the time, right?
Yeah, and you've touched so the way we filter suggestions is not it's not a clear-cut template, because some suggestions are very viable and open huge markets, but they open huge future markets. So we need just to hedge our investments in them. You touched on agriculture, so I'll just tell the story because I think it's a fascinating story. Look, one of the biggest applications for Stirling engine is in livestock, in biogas. There's probably, people estimate there's about 500 million people on the planet that have more access to animal manure than to clean energy. So if you could take this animal manure, digest the methane in it, put it in a Stirling engine and provide electricity, then you reduced all the pollution and you provide clean power, which is an amazing thing. The challenge is that unlike the oil and gas industry, typically third world farmers cannot afford our generator, right? But it's an enormous future market. So we have a great collaboration with a company called Sistema, where we just improve our product to this market. We install units, we test them. We actually we use it in a pig farm in Mexico when we take the biodigested gas, put it in the Stirling engine, and provide clean energy. So not all ideas that are not viable commercially today are not commercially viable in the future. You just need to have like thought through filtering mechanism where you filter your partners, like who is solid and you want to work with, and filter the applications. And you can say things like, look, in 5-10 years, our cost is expected to be X, and that will allow us to address this market. So let's start the testing, because this testing takes 10 years.
Yeah. It really sets you up. Yeah. Having that discipline, that commercial discipline, I think I'm going to borrow that from you, because it's quite a good phrase. That commercial discipline really offers more value and more opportunities in the future, because if you spread out too thin, there's only, you can only go so far, and you can only do so many things well. There's two things I want to touch on before I let you go, Ory, is you mentioned the oil OGCI, and I just wanted you to touch on exactly who that is. And the second thing, I just wanted to clarify something. We just had a guest on, Clark Gruey from a company called Rainmaker. He was a great guest. And he was talking about one of the roadblocks that Rainmaker helps companies sort of expand into new markets. And he was talking about one of the roadblocks companies face is like regulations in other countries and that. Because of the setup, because of what your engine is and, what it's doing, the environmental benefit of it and things like that. Do you have that roadblock? Are you able to pretty much go and sell directly into any country, regulations wise?
Okay, so I'll answer the two questions. The OGCI stands for Oil and Gas Climate Initiative. It's a consortium of major oil companies, and you can look on their website. All the oil majors, Exxon and Shell and Chevron and Repsol and Eni, most of them are also our customers, got together and built a multi-billion-dollar investment fund that invest in technologies that allow them to reduce their greenhouse gas emissions going forward. So that's their organization and their charter. They've invested in us in 2020, and we've been working with them for a while, and we are extremely happy about this collaboration, because it brings a combination of domain expertise and contacts that are hugely valuable to our company. Regarding regulation, and there's like push and pull in the sense that, for example, in Alberta, there is a list of technologies that are certified as climate friendly, and Stirling is one of them. So that definitely helps. Other countries or other locations are less aware of it, and it's a process until they'll be aware of it and have the same recognition. In terms of the other side of regulation is CE mark, UL, all these certifications that you need to work in a certain location. So we make sure that we have all the right certifications. Currently, we focus on North America, and as we expand into Europe and other places, we just certify our products to work in these locations. There's so much emphasis on quality in Qnergy that certification for us is more mechanical than doing anything differently.
Oh, I see. Oh, okay. Yeah. No, I was just curious, because obviously the application is applicable on a global scale. So I was just wondering if you go, yeah.
Right. Yeah. So we need to adhere to whatever each location has in terms of their requirements.
Right. Yeah. No. I hope, Ory, I hope we get you back on the show, because for one, I wanted that commercial discipline that your company has, the development. As you expand into new markets, there's so many things that I want to see, and I always invite people to come back on the show. But for your product, I really hope you do within the next year or the next two even. to sort of see where you at and see where the industry is at, because you're almost this gauge all of a sudden of where the industry is at on emissions. So it's quite a fascinating story to follow.
Excellent. Thank you so much.
Okay, thank you. Thank you everybody for watching the show. That's again, if you're watching the wrong show if that you don't find this topic interesting. It's an amazing product that Qnergy has brought to the market. It's amazing for the environment, for the oil and gas industry, for the other industries that they'll be expanding into over the next few years. So thank you for watching, everybody. Please keep suggesting guests to us, because we certainly can't find every guest to fill every episode, but we're getting great recommendations, and Qnergy is no exception. So please go check them out, and we will see you on the next episode of Crownsmen Energy.
Thank you so much for watching. Please remember to subscribe to our YouTube channel and follow us on Facebook and LinkedIn. If you'd like to be part of the show, whether it's Crownsmen Energy, Mining Now, or The Crownsmen Show, please contact us, info@crownsmen.com. Thank you so much for watching. Thank you to all of our sponsors. We will see you on the next episode.